Today we will see in details what is inter-process communication, and we are going to study in depth the two inter-process communication models. So let us begin with. Now there are two types of processes. One is independent process, another is cooperating processes. And independent processes means what? They will execute independently, and other processes will not be dependent on them. So something happens to, say, suppose this particular process P1, so then nothing will happen to another process. Then the second type of processes that we have seen was the cooperating processes. Like, say, suppose here P1 and P2 processes are there. So execution of any one of these process may affect the execution of another process. What is the advantage of using these cooperating processes? Obviously, first thing is that it will be information sharing. Then next is computation speed up, modularity and convenience. So these were the advantages of these cooperating processes. After this, the inter-process communication mechanism have to exchange data and information. So there are two models of IPC. So what is the first model? Shared memory model, and second is the message passing. If you recall it, message passing, what we have seen? We have seen that here in the message passing, kernel is involved. See, suppose process A wants to send message to process B, then it will send it to the kernel, and then the kernel will send it to the another process. So message passing, only small amount of data could be transferred and it is easier to implement. And what about shared memory? So in between these two processes, you can see here clearly there is shared memory among them. So here kernel is not directly involved. Now today we are going to see how actually this message passing IPC model works and how this shared memory IPC model works. Let us see the first model, that is the message passing. Now here if you can see this diagram, this M indicates the message. So process A wants to send a message to process B. So what is happening here? Now see here, in this model, communication takes place by exchanging messages between cooperating processes. So which are the cooperating processes here? Process A and process B. So these are cooperating processes and they want to exchange some information between them. So how they are going to do it? They are going to do it by sending the message. Hence this model is known as message passing IPC model. What happens in this message passing? It communicate and synchronize their action without sharing the same address space. Now these two cooperating processes A and B, they have their own independent memory space. Can you see here clearly? Process A is having their own independent memory address and process B is having its own independent memory address. Okay. So here in message passing, what is going to happen? They are not going to share the same address space. Okay. But they will be taking help of this kernel in this message passing. This type of model is particularly useful in distributed environment when communication process may reside on different computer connected by a network. Now, if you recall, in distributed type of operating system, I have explained you that the different computers may be present at different places geographically. So now this type of message passing model is particularly useful for this distributed environment, because say suppose if the particular computers are located at one place itself only, then they will be sharing the same address space. But here it is not the required, isn't it? So hence this type of message passing model is useful in distributed environment. Here basically communication means what? Sending and receiving messages through this kernel. If you recall, kernel is the core part of operating system. Then the processes that want to communicate with each other must have a communication link between them. Between each pair of processes, exactly one communication link is there. So here it is indicated by these arrows. Here you can see one link is shown from process A to kernel. Okay, that is number 1. Another communication link is represented by this arrow, number 2. So to enable the communication, we need to have the communication link. Second type of memory model is the shared memory IPC model. Now note here the difference. Here process A is there, process B is there. Again, these are the two cooperating processes, and in between them is the shared memory. So let us see what is actually happening in shared memory. See, in this, all processes who wants to communicate with other processes can access a region of the memory residing in the address space, and that is known as the shared memory segment. Can you see this shared part here between process A and process B? So say suppose I want that process A and process B should communicate with each other, then they must share a common space among them. Now see here, all processes using the shared memory segment should attach to the address space of the shared memory. Means both process A as well as process B will be able to access this shared memory address space. Now here how they are going to exchange information. Here both the processes will read and write in this same shared memory segment. Now in earlier case what has happened? Process A has sent a message to kernel, and then that message was then sent to the process B, isn't it? So here instead of that, what process A is doing? It will be writing that information in this shared memory, and then process B will read that whatever A has written from this shared memory. So reading and writing of information is done in this shared memory segment. The form of data and location are determined by these processes who want to communicate with each other. Means this process A and process B, okay, they both will determine that where the data is to be written and what data is to be written, and then they will communicate that with each other. See here, important thing is that kernel is not involved in this decision. Earlier the two processes has communicated with the kernel, but here now this process A and process B will communicate among themselves, and this kernel is unaware of this whatever sharing process that is going to take place. These processes are not under the control of operating system. Because why? Kernel is not involved here. So who is more responsible for this data sharing? Both the processes, process A and process B, are responsible for the communication. And then if it is their responsibility, then they should be ensure that they are not writing to the same location simultaneously, isn't it? Means if process A is writing in some location, in that same location process B should not write. Otherwise what will happen? Whatever process A has written, that will be overwritten, isn't it? So that is why both these processes need to communicate with each other prior sharing their data. So here kernel is not responsible for the communication. Who is responsible? Both the processes involved in the communication are responsible. Okay. Next, what is there? After establishing the shared memory segment, All accesses to the shared memory segment are treated as routine memory access and without the assistance of kernel. Means here what is happening is that process A and process B are going to take care of this shared memory space. Okay, and kernel will not be involved in any of this sharing of the information. So this is all about the shared memory inter-process communication model. In earlier diagram, we have seen kernel was involved, but here kernel is not involved. So in short, what is this inter-process communication model? We will revise it once again. So we have seen there are two types of processes. One is independent process, second is cooperating processes. There are advantages of cooperating processes. So cooperating processes are preferred in operating system. Now they need to communicate with each other. Cooperating process needs some mechanism to exchange the data and information among them. So that mechanism is known as inter-process communication mechanism. And then there are two types of models that we have seen. First one is the shared memory. Second is the message passing. What happens in shared memory? Shared memory, a common space is shared among the two cooperating processes. And in message passing, what is going to happen? Small amount of data through the messages are exchanged. So this is all about the inter-process communication model.